Imagine that you are sitting on a planet in the Virgo cluster. You find yourself 65 million light years away from here. You have a telescope of unimaginable power. A telescope so precise that it can see the continents on Earth. You can distinguish the trees, you see the ground moving. You adjust the focus knob and look at the surface of the planet. What do you see? You don't see us. There are no cities, no roads, no human beings. You see dinosaurs. You see T-Rex walking through a dense forest in what is now Montana. You see a giant fern swaying in the wind. Now here's the question that should keep you up at night. Does the dinosaur exist? You might say, of course not, Richard. The dinosaur is dead. The bones are on display in the museum. But wait a moment. For the alien looking through the telescope, the dinosaur is moving. It's breathing. It's hunting. The light coming from that dinosaur is reaching the alien's eye. Now, for the alien, this event is happening in the present. If you and I are here on Earth, we say that the dinosaur belongs to the past. But for the observer in the Virgo cluster, the dinosaur is in the present. So, who is right? Are we right because we're closer? Or is the alien right because he's witnessing the event? This leads us to a relevant realization, a disturbing one. A realization that completely destroys your notion of time. It suggests that the past, present, and future are not what you imagine. They are not absolute. They're like salami that can be sliced at different angles. Let's find out why. Let's understand why you can't trust your own eyes when looking at the stars. Let's understand why the universe is not a three-dimensional box that changes over time, but rather a four-dimensional block where everything that has ever happened still exists. But before we get into the heavy mechanics of space-time, let's start with something simple, something you can observe. Look at your hand. Move it from side to side. You see it move instantly, right? You feel the muscles tensing, contracting, and you see your hand move at the exact same moment. That's an illusion. It's a pretty convincing illusion, but it's still an illusion. The light that reflects off your hand takes a tiny fraction of a second to reach your eyes. It's about a billionth of a second. Your brain tricks you, making it seem instantaneous, but it's not. You are always seeing your hand as it was in the past. You never see the world as it really is right now. You are always seeing the ghost of reality. A billionth of a second doesn't make much difference when you're shaving or having coffee. But what if the distance is enormous? And what if the distance is on the scale of the solar system? Let me tell you a story about a guy named Olaus Rohmer. It was around 1676. An extraordinarily insightful man. He observed Jupiter's moons, specifically the moon Io. Io orbits Jupiter like a perfect clock, tick-tock. Every 42.5 hours it passes behind Jupiter and disappears. You could set your watch by it. It's a beautiful mechanical system. But Homer noticed something strange, something that just didn't make sense. When the Earth was close to Jupiter in its orbit, the moon Io appeared right on time. But when the Earth was on the other side of the solar system, far from Jupiter, the moon Io arrived late. It was off schedule. But why would a moon be late? Would it get tired? Would gravity change? No, the mechanism is perfect. Homer understood something that no one else had the courage to say. He said, "The moon is on time, it's the news that arrived late." The light that carries the image of the moon takes time to cross the solar system. When we are far apart, the light travels an additional distance. It takes about 16 minutes longer to cross Earth's orbit. That was a shock. You need to understand that before this, people believed that light was instantaneous. They believed that if you turned on a flashlight, the light would be everywhere at the same time, as if God could see everything simultaneously. But Rohmer showed that light is a traveler. It is a messenger, and like any messenger, it has a maximum speed. It travels at about 300,000 kilometers per second. That's fast, but it's not infinite. Because it's finite, using a distance flashlight would add more. Additional ignorance. We can only know what happened in the past. When you look at the sun, you are seeing how it was 8 minutes ago. If the sun exploded right now, we wouldn't know. We would stay here for 8 minutes feeling warmth and happiness. Gravity would still keep us in orbit. Sunlight would still shine. And then suddenly, 8 minutes later, the lights would go out and we would be thrown into space. Therefore, there is a delay. There is a gap between reality and our perception of it. But that's just the beginning. It's just the entry point. The main course is much stranger. Because if light has a speed, how is that speed measured? If I throw a baseball at 100 kmph on a train going at 100 kmph, I see the ball going at 200 kmph. I see the speeds add up. That's common sense. That's what Newton stated. But light doesn't follow those rules. If I point a flashlight from a train that's going at half the speed of light, the light comes out at the speed of light. If I'm standing still on the ground, the light still moves at the speed of light. No matter how fast the source is moving, no matter the speed of the observer, the speed of light is always the same. Now you should be saying, wait, Richard, that's impossible. You can't have a speed that's the same for everyone. If I run toward the light, I should certainly measure it going faster. No, you measure it at the same speed. How is that possible? How can the speed be the same if I'm moving? There's only one way to solve this. There's only one way to balance the equation. If the speed is fixed, then something else has to give. Space and time need to bend. If you run toward the light, your ruler must shrink. Your clock must slow down. You have to redefine the concepts of length and time so that the speed of light remains constant. This is where we enter the geometry of the universe. This is where we need to stop thinking of space and time as two separate entities. Imagine salami, a big, long salami. You can slice that salami straight and it gives you a perfect, even circle. Let's call this a slice. Everything in this slice happens at the same time. But suppose you tilt the knife. You slice it at a different angle. Now the slice is an ellipse. It's no longer a circle. And the content of that slice is different. You have a piece of meat on one end and a piece of fat on the other. That's exactly what happens when you start moving. When you start moving relative to me, you're tilting your knife. You're slicing the universe at a different angle. My now is a straight slice. Your now is a tilted slice. Once you're in motion, what I call the present, you might call the future. And what I call the past, you might call the present. Let's go back to our alien. The alien is 65 million light years away. Suppose he is standing still relative to Earth. His slice of the present cuts across the universe and reaches Earth right now in the 21st century. But he still can't see it because light takes time to get there. But now imagine that the alien gets on a bicycle, a very fast bicycle, and starts pedaling away from Earth. Just slow movement at walking speed. Even so, because he is in motion, he tilts his slice of the universe. The angle of his now shifts because the distance is gigantic, 65 million light years. A slight tilt of the knife on the alien's side turns into a huge leap in time on Earth's side. If he pedals away, his slice of the present tilts toward the past. Suddenly, his now doesn't contain the 21st century, it contains the Jurassic period. It's not just that he sees the light from the dinosaurs. It's that for him, according to the geometry of space-time, the dinosaurs are the events that are simultaneous with his bike ride. If he turns his bike and pedals toward Earth, his slice tilts toward the future. His now contains events on Earth that haven't happened yet. He is simultaneous with our great-grandchildren. Therefore, you see the problem. If different observers can slice the salami at different angles, then all parts of the salami must be real. You can't say that only the middle slice exists, because my middle slice is your end slice. This suggests that the past hasn't gone away. It's just further down the salami. It suggests that the future isn't empty. It's just further up the salami. It suggests that we live in a block universe, a frozen four-dimensional block where everything simply exists. The T-Rex is still hunting in the dense forest. Napoleon is still fighting Waterloo. You are being born. You are dying. All of this is there in the geometry of spacetime. Now, this is a very disturbing idea for us human beings. We like to believe that we have free will. We like to think that the future is open. We like to imagine that we are creating reality as we go along. But the physics of light suggests that the film has already been recorded. The film has already been developed. We are just the projector's beam passing through the frames. But wait, it gets deeper. We need to talk about why this speed limit exists. Why is there a speed of light? Why isn't it infinite? If the speed of light were infinite, cause and effect would be a complete mess. If I could send a signal instantly, I could tell you the lottery numbers before they're drawn. We could create endless paradoxes. The universe seems to have this speed limit specifically to protect causality, to make sure that the cause always comes before the effect. Think about the interaction. What really happens when you see something? It's an interaction between charged particles. You have an electron in the sun, it oscillates, it's hot, so it vibrates continuously. When the electron oscillates, it creates a disturbance in the electromagnetic field. I don't want you to think of a field as a mathematical sheet of paper. I want you to think of it as a fluid or a jelly that fills the entire universe. When the electron oscillates, it stirs the jelly. A wave spreads out like ripples in a pond. Those ripples travel outward. They move at the speed of light. Eventually, they reach an electron in your eye, and that electron oscillates. Therefore, seeing is just a delayed oscillation. It shakes here, waits a while, and vibrates there. This is the fundamental law of the universe. Delay is the price we pay for existence. If there were no delay, if everything were connected instantly, everything would happen at the same time. There would be no history. There would be no unfolding. It would just be a single instantaneous flash of everything at once. The fact that light takes time gives us the necessary separation to be individuals. It gives us the privacy of our own now. But it also makes us incredibly lonely. Think about it. You never touch anything in the present. When you touch the table with your finger, you feel the pressure. But what is that pressure? It's the electrons in your finger repelling the electrons in the table. It's the electromagnetic force. And this force is transmitted by photons, tiny particles of light. And these photons take time to travel the tiny space between your finger and the table. Therefore, even when you touch something, you are feeling the past. You are feeling the table as it was a fraction of a second ago. You are never truly in contact with the world at the exact same moment. You are always chasing the instant. All of us are trapped in our own little temporal bubbles, sending messages to each other through the void. I'm here, I feel it. And by the time you hear me, I'm already different. I've already changed. That's the tragedy and the beauty of all this. So let's go back to the alien. The alien sees the dinosaur. Is the dinosaur real? Yes. In the great block of space-time, the dinosaur is just as real as you and me. It occupies a coordinate in the four-dimensional manifold. The alien sees us. No, we are in its future. From its perspective, we're still waiting to happen. But does that mean we don't exist? No. We exist in our slice. The world is dynamic when you observe it locally, but static when you consider it globally. It's like a musical score. The symphony is written on the page. All the notes are there. The beginning, the middle, and the end. They exist simultaneously on the page. But for the musician performing the piece, he experiences it one note at a time. He experiences the flow of time. We are the musicians. We are interpreting the score of the universe. We can't see the whole page. We can only play the note we're on. But physics tells us that the page exists. Now you might ask, Richard, is there any way to cheat? Is there any way to go faster than light and see the future or change the past? As far as we know, the answer is no. If you could exceed the speed of light, you could outrun your own light. You could turn around and see yourself leaving. You could arrive before you had left. You would break the causal chain. The universe seems to hate that. Every time we try to find a loophole in physics, nature slams the door on our fingers. No peeking, it says. So, we're left with this. We're small creatures living on a small rock. Our view of the universe is delayed. Our view of each other is outdated. We're building our reality from old news. But what extraordinary news is this? The fact that we managed to discover all this? The fact that a biological machine like the human brain, using only eyes and logic, can deduce the geometry of four-dimensional space? That's a miracle. We're just primates in clothes, but we managed to glimpse the blueprint of reality. We discovered that we are part of a huge tapestry, a tapestry woven with light and time. And even without being able to see the whole picture, we know the threads are there. So, the next time you look at the stars, remember that you're looking at a time machine. You're contemplating ghosts. And somewhere out there, 65 million years away, an alien might be watching us. Or looking at where we should be. And he sees a T-Rex. And in a way, funny enough, he's right. And we're right too. Because in the physics of space-time, everything that has ever existed and everything that will ever exist dances together in the silent geometry of the universe. It's a block world. It's a world that doesn't match our common sense. But as I always say, nature has no obligation to make sense to you. It is what it is. And our role is simply to enjoy the enigma. So go outside, look at the sky, think about the delay, think about the salami, and realize that you are spread out through time in a much more majestic way than you ever imagined.